How do we navigate space with an innate sense of direction? How do we find routes in unfamiliar locations? The answer is in a phenomenon that not only helps us navigate our environment, but also has a role in preventing serious cognitive diseases, such as Alzheimer's disease. Let's jump in.
Navigating from place to place can be attributed to spatial navigation. The key to spatial navigation lies in the brain's hippocampus and its neighboring structure, the entorhinal cortex. They are the brain's specialized map readers for navigating the spatial environment, helping us determine where we are and how we got there. This correlation between the structures and navigation is why using navigational skills can cause the hippocampus and brain to grow. That's why taxi drivers tend to have a larger hippocampus than the average person. In the hippocampal region, there are 4 types of cells that regulate navigation. They account for spatial inputs that allow us to recognize distance, location, direction, and reorientation. They were discovered by inserting electrodes into the hippocampi of rodents, which recorded the location where electrical pulses were fired by these cells. The regions where they tended to fire are called the place fields of the cell. Place cells fire when an individual enters the place field of a cell, which is how we interpret locations in our environment. There are thousands of place cells and place fields that account for all of the places in our spatial environment. The collective place fields develop an inner map, known as the cognitive map. Every time you enter a new place field, you're at a new location in the cognitive map. Head direction cells fire when the individual is facing a certain heading direction. So if a specific head direction cell is set to fire at due north, then it will always fire when the individual faces that direction. They help us navigate towards a desired location and direction and assist us in following directions. Grid cells fire in such a way that the place fields form a hexagonal grid. They're responsible for recognizing displacement in the x and y directions relative to an external reference point. We can do this because when grid cells fire after entering another place field, since they're at a uniform distance away from each other, they act like tick marks on a ruler. Grid cells can also be used to find out position. Our brain piles thousands of grid cell modules on top of each other like so, and interprets each unique intersection as a unique location in our cognitive map. In border cells, the place fields are oriented around navigational barriers of the environment which we move around in. The cells represent your position with respect to those barriers. They allow us to respond when faced with impassable objects.
Exercising our spatial navigation skills is essential. Studies have shown that using a GPS excessively could lead to atrophy in the hippocampus, which could progress into cognitive diseases such as Alzheimer's, which impairs spatial orientation and memory. Researchers found more gray matter in a group that used more spatial navigation skills. That group also scored higher on cognitive tests. These studies demonstrate that using orienteering and building cognitive maps is better for the brain than using a GPS excessively. Utilizing our spatial navigation skills can benefit us greatly, from our health to our intellectual aptitude. So the next time you go adventuring in your community, try using your very own cognitive GPS.